This is another video on basics of vectors. A vector multiplied or divided by a scalar. Make sure you spell scalar correctly. It has two A's in it and no E's. This is not an E right here, it's an A. Any vector multiplied or divided by a scalar yields another vector. These two vectors are always directed either parallel or anti-parallel to each other. If they're parallel to each other, the scalar would be a positive number. Should I draw some in here so you can make sure you got, oh, there you go. That's what we mean by parallel. Anti-parallel, one points one way, the other vector points the other way. So occasionally we'll get something like that as well. But if you take a vector and multiply or divide by a scalar, you get another vector. So here are some equations that you may recognize. Let's put a vector arrow over the vector quantities. So acceleration is a vector, velocity is a vector. How about this? Velocity is a vector, displacement is a vector, time is a scalar, so no touchy that. Force is a vector, acceleration, but mass is a scalar, so no touchy that. Momentum is a vector, velocity is a vector, moving right along here, velocity, velocity, acceleration, not time. Displacement, velocity, velocity. So far, so good. This looks pretty easy. Displacement is a vector. Velocity is a vector. Acceleration is a vector. There you go. A couple things. Some things that we're seeing here. Let's look at this momentum equation. A vector, like velocity, multiplied by a scalar, like mass, gives you another vector, momentum. Perfect. How about number one here? A vector, namely change in velocity, divided by a scalar gives you a vector. So these equations illustrate that statement there at the top of the screen. A vector multiplied or divided by a scalar yields another vector. And these two vectors are always directed parallel or anti-parallel to each other. Perhaps we might want to add something here at the bottom if you have room. These vectors in any equation must point in the same general direction. For example, all x direction or all y direction. Let's use one example right here, which you might have run into in studying projectile motion in an earlier physics class. When we have here, as you can see, this is in the upper right corner of your screen. When we have a displacement and we have a velocity and we have an acceleration, all those have to be the same general direction, like all in the x direction or all in the y direction, or in terms of projectile motion, all in the horizontal direction or all in the vertical direction. You cannot combine an acceleration that's in the vertical direction with a displacement that's in the horizontal direction, and so on. Hopefully that was drummed into you in an earlier physics class, but I thought we should reinforce it here one more time.